Okay, can you guys see my screen?
Yes, and if you'll just, yeah, there we go.
And can you see it moving forward as well?
Yes.
Okay. Okay, so hello everyone, my name is Muhammad Asad and I am a PhD student in, I'm doing PhD in Energy Science and Engineering at University of Naples, Parthenope in Italy. And today I will be presenting my work on multi-criteria analysis to evaluate functioning of photovoltaic power plants in Pakistan. Okay, so this is the sequence of my today's presentation. So first of all, I would like to talk about Pakistan energy mix. So as we can see that Pakistan is highly dependent on oil and gas to produce and to fulfill its energy needs. So according to a survey, Pakistan energy demand is approximately 26,000 megawatts and its production and distribution capacity is stalled at around 22,000 megawatts, which leads to 4,000 megawatts of energy deficit when the peak demands mostly in the summers. So this is the solar energy potential map of Pakistan. And as we can see that we have a lot of energy, solar energy potential. We get around 7 to 9 daily sunshine hours and with a lot of high solar energy potential in our southwest region of Pakistan. So to get maximum benefit from the solar energy potential that Pakistan has, it started, to build a solar photovoltaic power plant that has the capacity of 100 megawatt, and it was completed in 2014, back in 2014. And they were supposed to build it and enhance its capacity to 1000 megawatt, but I don't know why they haven't done it. So anyway, so basically we can use solar energy to produce electricity or heat by using two technologies, photovoltaic or solar thermal. So as we are focusing on photovoltaic, so I will talk a little bit about photovoltaic solar energy plants. And this is actually how it works. The working principle is, of course, of a photovoltaic effect, which produces electrical current when sunlight falls on the solar plates, and then we can use those electrons or electrical energy for our households or anywhere else. So there are mainly three categories in which we divide photovoltaic technologies. One is monocrystalline, polycrystalline, and thin film technology. The most mature one technology is the polycrystalline technology, which the QA solar plant in Pakistan is actually using, as it is more mature and its cost is low, and it has also good performance under high temperature and under severe circumstances, you can say. So the objective of our study is to build a model using the AHP to investigate the factors that are necessary to take under consideration to install a photovoltaic plant. They can be considered anywhere, whenever, wherever you want to install a power plant, but we did this study focusing on the environmental conditions and criteria of Pakistani environment. So model building, we applied AHP to build the model, and the model was built by an expert team found by one AHP expert, two experienced photovoltaic plant engineers, and one expert in logistics and one expert in feasibility projects. The model is based on information of secondary resources like literature review and pool of experts. Goal, criteria, alternatives, influences, and judgments were obtained following the meetings of the expert team. Judgments were aggregated through the geometric means. So the model is found by three criteria: economic, technical, and the land. Furthermore, the model is found by 10 sub-criteria: payback period, present net present value, internal rate of return, irradiance, temperature, wind, water, reduction in the carbon emissions, etc. This was the model that we built by using ISAHP technique, and the results indicate that the most significant criteria when evaluating the overall effective factors for the correct functioning of the PV plants were land. It has 45% of the weightage percentage, which can be explained as the Bahawalpur is a desert terrain with a high number of dusts. So the efficiency of the photovoltaic plates can, get reduced by 40% if they are not cleaned properly. So where we exactly are going to build a plant, it really matters. And this is why this criteria has the most highly rated. The second relevant criteria is the economic, followed by the technical, and the most important sub-criteria was water in our study, which can be explained as so these solar panels are like 400,000 in to produce 100 megawatt of energy, and it will take around for 15 days it will take around 124 million liters of water to clean all of these panels. But due to a little bit rain we get in that region, in like 3 4 months we get rain around for one or twice, so the panels gets washed naturally. So this is why the efficiency is not compared. So, and the second most important sub criteria is the temperature. For the months of June and July, you can say the temperature goes very high, like above. Sometimes it crosses 50-degree as well. So the efficiency of the plant can, can reduce. So although the Qaeda solar plant is working on its full capacity, the efficiency is not affected much. Anyway, so the based on this study area priorities, a guide map was carried out to assist the decision-making process to establish new photovoltaic plants in Pakistan weather conditions. And these are my some references. Thank you for your attention.
Great job. Any questions from the group?
Thank you, Asad, for a very interesting presentation. May I know, under the criteria land, what are the sub-criteria? I'm wondering whether
Under the land?
Yes. What are the sub-criteria?
Yeah, it's the irradiance, temperature, and reduction in the carbon.
Okay.
Yeah, carbon emissions.
Yeah, there wouldn't be any social or environmental factors, criteria affecting
Under,
may come under. So I was just wondering, please.
sorry, I didn't get it.
Uh, I couldn't see any social and environmental aspect or factors.
Actually, temperature and irradiance is an environmental, you can say, impact,
I see.
and also
Okay.
carbon emissions. But we did not include it social because, as we have.
Sashi, I am Antonella. And your observation is very, very good. In fact, this is a pilot project, and the social criteria will be included in the development of the project. This is only a first experimentation, but with Muhammad, we are working on a more complex HP model, in which we include,
Very
of
nice.
course, also social aspect. Thank you for your
Thank you.
observation.
Yeah, thank you.
Thank you, ma'am.
Other questions, comments? So if those are all our questions.
Sorry, I was trying to connect. I just have a comment, if I may.
Yeah.
Yeah. I didn't like this implementation and of the IHP, and I think that one important thing that you did in your work is that you connected the relevance of the different criteria to concrete issues or concerns in developing these technologies in your country. For example, I see that the dust is an important issue. I didn't think about it, but also water. So it may be interesting now that you're also trying to include the social issues to check the trade-off of using water either for the local
Drinking
inhabitants or whatever to
Yes.
and to this technology and see how your changes value. What you're feeling about that?
Yeah, exactly. In recent research about water in Pakistan, we are gonna have a deficiency in water as well. And still around, I guess, 8 to 9% of the population in Pakistan have no access to clean water.
Mm-hmm.
So it can be a issue, you can say.
And maybe
future as well.
you to
As
measure
we
the
are
trade-off.
shifting, yes, as I
sorry.
am saying that as we are shifting to renewables, so it will, require more and more water as well
Yeah.
when you build more and more plants.
And you may consider to implement the POCR model, benefit, opportunities, costs, and risk analysis to measure the trade-offs with the social issues. And in that respect,
Yes.
very interesting, very inspiring. Thank you.
Thank you, sir, for your comments.
Good perspective there, Luis. Other comments?